On January 1986, the Space Shuttle Challenger exploded after 73 seconds after liftoff, killing 7 crew members, including Krista McAuliffe, a teacher that was going to do the first class broadcasted from the space. After 32 months, the investigation pointed out to the failure was coming from a toroidal joint, common name for an O-ring. O-rings manufacturing process always include a final visual inspection to prevent bad O-rings to be shipped out, and then prevent major or catastrophic failures. How can we have a reliable inspection system? How can we assure that the inspector has high performance? In this video, we walk together through the steps to build a successful and reliable inspection system, regardless if it's human or machine-based. We will learn how to do it by using Attribute Agreement Analysis method, also known as Attribute Gage R&R. So how to build a reliable inspection system? Let's review the basics. The inspection analysis always ends with an attribute output. The attributes are going to be classified in 3: binary, nominal, and ordinal. Binary is the common pass-fail. The nominal is a label given to the defects and are independent from each other, like for example painting defects. The third one is the ordinal and is commonly represented with stars or ratings. So the steps that we are going to follow to develop and build a high performance inspection system are going to be the following. First, we need to define and select the master samples. Second, you need to select the inspector or the inspection system. And third, we need to perform the study. As an output, we are going to identify what training is, where training is needed. We are going to identify also if procedures or control plan has some opportunities for improve, if the standards are not clearly defined, and also if the gauge needs some adjustments or if it's correlation required. How we are going to define and select the master samples? First, we need to write down a failure mode list that can come from the customer. It can also be pulled from the FEMA or the list of rejects that we have had through the history. Next step is review with the expert. That could be the customer, it could be also some internal expert that is going to help us to define what is and what is not a defect from this failure mode list. And then we are going to document this standard, this list and classification that we get from the experts. There are some industries like the electronics with the IPC. In the case of the O-rings, we are going to have burns, short shot, flash, deformation. And these standards define very clearly what is a defect and what is not a defect. How to select the correct inspector? Well, first we need to identify people that has the right skills. These skills are defined or rated with generic tests that are evaluating the ability of the person to detect some abnormality. We also can develop our own test. In this example, we make squares when we need to detect the abnormality. We design units or examples with defects and some without defects. At the end, we look for how many good and bad results the candidate to be an inspector has. Then, after screening these persons, we need to observe that they have experience as an inspectors And finally, we need to train them on the standard. So they are going to know the standard before we go to the evaluation of the system. In the case of an inspection system, automatic inspection system that are very common nowadays, we need to make sure that the cameras, in case of a vision system, has the right resolution, that the software is properly built and doesn't have any bugs, and if it's reliable. So we need to test multiple times in extreme situations. We need to observe that the light, the ambient light, doesn't affect the results. So very important for optical inspection systems. Ready to the analysis. First, we need to select at least 30 samples in case that we are doing a good-bad study, a binary study of attributes. We are going to have 50% good, 50% bad. Very important to say that the bad units are going to be or need to be marginal bad units, because if we select obvious bad units like burned units or completely damaged units, are going to give you a false sense of good results when it's not really happening. We want that these inspectors should be like the master. So it's like having the master, the customer, the most experienced person right in the spot. So very important when you build this sample, this master sample for testing, you need to avoid building patterns like all good, all bads, or good, bad, or any ascending or descending order. Because especially the human, when they don't know the answer, they are going to fill out with this pattern. Minitab is going to be capable to provide or to analyze independently 10 different defects. This is a very cool feature because it's going to allow us to identify where is the opportunities for improvement. The Attribute Gage R&R is looking for consistency and correctness. We are doing that, rating the accuracy of the appraisal. They need to say the same every time for the same unit. The result should be the same for each unit in the different trials. And also, we are going to rate the inspector or the inspection system against the standard. This is the ultimate measure that we need to get approved, and in order to approve it, we need to be over above 90%. It's very important to mention that we need to keep during the analysis the operative condition. What I mean with operative condition, the lighting, the environment, and the timing should be exactly the same as the station. So we can approve an inspector that is not really capable to do the job. In this example that we have on the screen, we are going to see the results that we already collect from the 3 operators. 3 times we select 50 samples, and these 50 samples were repeated these 3 times for each one of the inspectors. And commonly the collection of data in the floor is going to be following different format, like this, for example, where we put the different trials and what was the inspector on each one. But Minitab is going to require a different array. In the Minitab, we need a column for the sample, a column for the master information or the master tag for each unit. We need to have the inspector, the name of the inspector, then the result, and if you want, it's not necessary, but it's good to have the number of trials. So I'm going to select all of these samples, and I'm going to take to my Minitab. So here in my Minitab, I'm going to go to the Stat menu, the Quality Tools, and it's important to don't go to the Gage study, because in the Gage study we are going to see this Attribute Gage Study Analytic Method. That is not the good one. The good one is this, the Attribute Agreement Analysis. In the Attribute Agreement Analysis, we are going to select the result or the attribute that the inspector gives to each part. We need to put the number of samples. That sometimes we use the serial number, or we can assign a specific number for the sample. In appraisal is going to be the name of the inspector or the name of the equipment that we are evaluating. And very important to select down here the non-standard. So this is going to be, of course, the master. So it's important that we have classified as a Minitab is going to require all the information from each concept in one column. Something that I always mention is go to this information menu here, because when you elaborate multiple Gage R&R for different inspectors or different shifts, different machines, etc., when you have several files, you are going to require these details: what day you did the study, who was doing this study, who report, what was the product, and if there is some special characteristic that you are following. Okay, here I'm going to hit OK because I have everything completed, and Minitab is going to give me this chart. These charts are going to have this element that is the confidence interval, this line around this point. But what I want to see is the result within appraisal that is going to refer to the operator again itself, and here are going to be the appraisal versus standard. That is really the one that I'm looking for. Each operator needs to be good versus the standard. So I can go here. If you have version 17 and early, you can go here to this icon, and you are going to see the result or the summary of results. So here you can see how many pieces each one inspect, what match, and that is within appraisal. You can see the number of kappa that, as we said, 0.75 is the minimum. So we are good, our inspectors are good, but we don't have the 90% that we are looking for this inspector in order to have a good inspector. So this inspector require more training. Maybe these inspectors are not ready to be released to the line. So but we know that for example here John is the best of the three, and Anna needs a little bit more of a training or assessment. So our training department can be working with them and see what are the areas for improvement. Here in the place kappa statistics, we can see the kappa level, and you see bad and good. So we can
observe where is the criteria where they have the most mistakes. So here we can say, and John is going to have the best performance. We need to work with them, and we are going to perform another Gage R&R after this retrain or recertification. But in this example, we need to work more with our guys.
In order to have high performance inspector, we need to have the right people, we need to have the right samples validated with the master or by the master, we need to perform the study, and we need to have agreement of the appraisal versus the standard over 90%. If we achieve that, we are gonna be able to deliver exceptional quality to our customers. I'm Fernando Rodriguez. Thank you for watching this video, and we will have more of these videos pretty soon. Thank you.